Welcome to question number 17. Prove cos pi by 12 and sin pi by 12 are irrational. All of you must have seen my video on rational root theorem. If not, please do so here. We have seen that rational root theorem can be used to verify whether a polynomial has rational roots or not. I'm going to use the same principle to answer these questions. Let's start with the known value of cos pi by 6. What is cos pi by 6? It is square root of 3 by 2. We'll start from there. Okay, I can rewrite this cos pi by 6 in this fashion. I've just multiplied and divided by 2. That's it. So I can apply the cos 2x formula here, right? So this I'm going to write it as cos 2 times pi by 12 equals square root of 3 divided by 2. Now let me call pi by 12 as x. Just for the sake of convenience, every time I need not write pi divided by 12. So I am going to write pi divided by 12 as x. So this goes. Okay, next I am going to use the cos 2x formula. Cos 2x is cos square x minus sin square x. Now, I want only cos terms here. So instead of writing sin square x, I am going to write it as 1 minus cos square x. Okay, now if you have seen our rational root theorem video, we said all coefficients should be integers. But I have the square root of 3 here. So what do? I can square both sides, right? I want to simplify this, then square. Okay, so if I square this, I'll get 16 cos to the power of 4x minus 2 multiplied by 2 multiplied by 4 cos square x. That is 16 cos square x plus 4 equals 3. So subtract 3 from both sides, you will get 16 cos power 4x minus 16 cos square x plus 1 equals 0. Okay, so this is a polynomial of degree 4 on cos x. We can write it as, let us say, let's call cos x as some k, okay? So this can be written as so this is a 4th degree polynomial on k. Now, from our rational root theorem, a0 is 1. An is 16, therefore p divided by q will be integer factors of 1 divided by the integer factors of 16, correct? Factors of 1 plus or minus 1. Factors of 16 plus or minus 1, 2, 4, 8 and 16, correct? Okay, now we have to check each and every combination to see whether this has rational roots or not. Therefore, the possible rational roots are okay, let me list out the possible rational roots. It is so these are the possible rational roots. Now I have the negative term, that is minus 1, minus half, minus 1 by 4, minus 1 by 8 and minus 1 by 6. Actually, we did not check these numbers because Both are even powers. So whether you apply plus 1 or minus 1 or plus half or minus half or plus 1 by 16 or minus 1 by 16, it doesn't change. So we are going to check only for the positive values. Okay. So first P of 1. So when you apply P of 1, you have 16 minus 16 plus 1 not equal to 0. Next is P of 1 half. So you have 16 half power 4 minus 16 half square Okay, now 16 2 power 4 get cancelled because 2 power 4 is 16. Next you have 16 divided by 2 square, that is 16 divided by 4 plus 1, definitely not equal to 0. Next, let's apply P of 1/4. Now 16 divided by 4 square will get cancelled, definitely not equal to 0. Next, let's apply P of 1 divided by 8. Okay, next we are going to check 1 divided by 8. Okay, so when you apply 1 divided by 8, you have 16 multiplied by 1 divided by 8 power 4 minus 16 multiplied by 1 divided by 8 square plus 1. I have factored out 16 here, so I have 1 divided by 8 power 4 can be written as 8 square multiplied by 8 square, that is 64 multiplied by 64 minus 1 divided by 8 square, 64 plus 1. 64 multiplied by 64, common denominator, you have 1 minus 64, not equal to 0. So 1 by 8 is also not a rational root. Next we are going to apply 1 by 16. Okay, so I have applied 1 by 16. So you have 16 multiplied by 1 divided by 16 power 4 minus 16 multiplied by 1 divided by 16 square plus 1. Factor out 16. 16 square is 256. Therefore, you have 1 divided by 256 multiplied by 250. That is 16 power 4 can be written as 16 square multiplied by 16 square. So 256 multiplied by 256 minus 1 over 256. Then take 256 multiplied by 256 as a common denominator. You have 1 minus 256. Definitely this is not equal to 0 because 16 multiplied by minus 255 divided by this plus 1 not equal to 0. Therefore, we have applied all the possible rational roots, including negative numbers, because if you apply negative numbers here, the result will be the same because all these are even powers. Therefore, the k has. Okay, so I have applied P of 1 over 16. What I get? 16 multiplied by minus 255 divided by 60 to the power of 4 plus 1. This is definitely not equal to 0. Therefore, as per rational root theorem, our polynomial 16k power 4 minus 16k square plus 1 has no rational roots. What does it mean? So, our polynomial has no rational roots. That means k, which is equal to cos x, which equals to cos pi by 12, is irrational. Proved. Let's go to sin pi by 12. Next, let us prove sin pi by 12 is irrational. If you have noticed, I have not scored out the entire board. I have retained many of the things from the previous proof. Why? Because I am going to use the same principle to prove this. Let's see. As before, let us start with sin pi by 6. Sin pi by 6 is 1/2, correct? And I'm going to write sine pi by 6 as sine 2 multiplied by. So I'm going to write it as sine 2 multiplied by pi by 12 equals 1/2. And as before, let's write pi by 12 as x. And sine 2x is 2 sine x cos x. Okay. Now cos x can be written as square root of 1 minus sine square x, because I want to maintain only sine in my equation. Okay, as before, let us square both sides. So you have 4 sine square x multiplied by, we already have a square root sign here. So 4 sine square x multiplied by 1 minus sine square equals 1 divided by 4. Okay, so let's simplify this. So we have 16 sine square x, 1 minus sine square equal to 1. So this can be written as okay, so we have 16 sine power 4x minus 16 sine square x plus 1 equals 0. Then let sine equals k and rest of the argument follows. So if you take sine x equals k, you have 16k power 4 minus 16k square plus 1 equals 0, and rest of the argument follows. Finally, we have hence k equals sine x, which equal sine pi by 12 is irrational. So proved. So that's the proof of cos pi by 12 and sine pi by 12 are irrational. Thanks for watching. There was something that left me unsatisfied after I finished the question number 17. Okay, our polynomial 16 cos power 4x minus 16 cos square x plus 1 has no rational roots. But what about the actual roots of this polynomial? In other words, write down the solution set of 16 cos power 4x minus 16 cos square x plus 1 equals 0. And that's our question number 17a, sort of supplement to question number 17. Let's do it. So our polynomial is this is actually a quadratic in cos square x. How? Do you see? This is a quadratic in cos square x. That is, let's take cos square x as some k. You will have 16k square minus 16k plus 1 equals 0, right? Okay, now I'm going to apply the quadratic formula, that is minus b plus or minus square root of b square minus 4ac divided by 2a. So I have minus of minus 16 square root of b square, that is 16 square, right? Let's simplify this. Okay, so I have written it as two terms. Minus of minus 16 is plus 16 divided by 2 multiplied by 16 plus or minus square root of, I have factored out 16 here, 16 multiplied by 16 minus 4, that whole thing divided by 2 multiplied by 16. Let's simplify this further. This 16 get cancelled, so I have 1/2 Okay, so this is what we have. 1/2 plus or minus 16 square root is 4. I've taken that out. Then multiplied by square root of 16 minus 4, 12. 12 can be written as 4 multiplied by 3, right? Then square root of 4 is 2. So 4 multiplied by 2. Square root of 3 divided by 2 multiplied by 16. Now, four multiplied by 2, 8. 8 by 16, you will get 1 by 2. So you will have 1/2 plus or minus square root of 3 divided by 4. Then let's take 4 as common denominator. 4 as common denominator, so you will have 2 plus or minus square root of 3 divided by 4. So this is our cos square x. Then what is cos x? So what is cos x? I am taking square root of this number here. We have divided by 4. So you take square root of 4 is 1/2. Since we are taking square root, you have plus or minus sign. So plus or minus 1/2 multiplied by 2 plus or minus square root of 3. But you have to take a square root of the whole thing. So you have plus or minus 1/2 square root of 2 plus or minus square root of 3. So this is our cos x. Okay, so what is x? X should be cos inverse of, there are how many terms here? There are 4 terms. You have plus half 2 plus square root of 3, or rather plus half square root of 2 plus square root of 3, then minus half multiplied by square root of 2 plus square root of 3, then plus half square root of 2 minus square root of 3, then minus half multiplied by square root of 2 minus square root of 3. Therefore, x equals cos inverse of so this is one value, that is also equals this is the other value, this is the third value, this is the fourth value. So we have 4 solutions here and we have to write down the complete solution set. That's the question, right? So this would be the cos inverse of half multiplied by square root of 2 plus square root of 3. The values are, rather the principal values are pi divided by 12 or plus or minus pi divided by 12. Okay, plus or minus pi by 12 is only the principal value. What about the entire solution set across set of all integers? It will be plus or minus pi by 12 plus or minus 2 pi n. Okay, next. So this would be plus or minus 11 pi by 12. The entire solution set is plus or minus 11 pi by 12 plus or minus 2 pi n. Okay, next. This is the principal value is 5 pi by 12 plus or minus 2 pi n. Similarly, this will be plus or minus 7 pi by 12 2 pi n, where n is set of all integers. Okay, so this is the entire solution set and the general solution set can be written as so this entire solution set is contained in this, that is 1 divided by 6 pi n plus or minus pi, where n is set of all integers. So this is the final solution set for this equation 16 cos power 4x minus 16 cos square x plus 1 equals 0. Thanks for watching.